Hi, this is Vijay Kumar from Naresh Technologies, and today I am going to discuss about indexes, one of the most important topic in Oracle. So, what is index and what for indexes are created and how a index works then. So, index is a database object that makes data retrieval faster. So, what index makes? Index makes data retrieval faster. A database index works the same way as a textbook index. So, in textbook, every textbook comes with indexes. Why? Because using that index, a particular topic can be located fastly. If textbook does not come with index, if you want to locate a particular topic, you need to go to each and every page to locate the particular topic. So, if textbook comes with index, then we will go to the index, we find out the topic. Once topic is found, it is associated with page number, we can go to that page directly. So, a particular topic can be located fastly with the help of index. So, however a textbook index works, the same way a database index works, but in textbook we try to locate a particular topic, but in database we search for particular record. In textbook the search is for particular topic, but in database search is for particular record. So, with the help of this index, records can be located fastly. Okay. So, with the help of this index, Oracle can locate the records fastly, and we create index, but index is created on what? Index is created on columns. You create index on, suppose for example, salary, you create index on job, you create index on e-name, you create index on department number, you create index on columns, and the column on which index is created, and that column is called index key. For example, if you create index on, if index is created on employee number, and employee number is called index key. If you create index on salary, and salary is called index key. So, the column on which we create index, and that column is called index key. Next, indexes are mainly two types. One is bit tree indexes and another one bitmap indexes. So, when it comes to Oracle database, indexes are here categorized into two categories. One is bit tree indexes and another one bitmap indexes. So, these categories are based on the structure internally created, because if the index is bit tree index, internally one tree structure is created. If the index is a bitmap index, so internally one structure is created that contains bits, and if bitmap index is created, one structure is created that contains bits. So, that is why it is called bitmap. Then first we will start with the bit tree index. We will start with this bit tree index. Then, so I want to create bit tree index. Then, so how you create the bit tree index? What is the command to create the bit tree index? And this is the command, create index, index name. So, I am creating a index, index is I1 on which table and which column you want to create index. So, what I said, indexes are created on columns. So, I want to create index on salary, but and the salary column belongs to which table, and the sal belongs to a table called EMP table. So, I want to create one index, and I want to create this index on salary column, and this index belongs to EMP table. Like actually question is, why you create index on salary? Because for example, so I am executing a query. What is the purpose of creating index is, index makes data retrieval faster. For example, I am executing a query, select star from EMP where salary equals to 3000 for example. So, I am executing a query, select star from EMP where salary equals to 3000. So, assume this query is taking more time to, Oracle is taking more time to locate the record salary equals to 3000. When user submit this query to Oracle server, assume Oracle is taking more time to locate the records, salary equals to 3000. Okay. So, I want to improve the performance of this particular query. So what I am doing is I am creating an index to make this operation faster. Okay. So to make this operation, locating the record salary equal to 3000, to make this operation faster, so I am creating an index. So I am creating index on salary, because the set is based on salary, that is why I am creating index on salary. If the set is based on ename, then create index on ename. If the set is based on department number, create index on department number. But in this query, the setting for the record is based on salary, so that is why I am creating index on salary. Then, so I will execute this command. So go to Oracle, I am executing this command. See this, after executing this command, you got a message index created. Okay. Then after executing this command, you got a message index created. So index created, and plus at the time of creating index, I did not mention whether it is B-tree or bitmap. If you do not mention B-tree or bitmap, by default what type of index is created is B-tree index is created. So what the default index is B-tree. So I did not mention whether I am creating B-tree or bitmap. You do not mention anything by default. So what Oracle creates is B-tree index is created. When index created means internally one structure is created, and that structure looks like a tree structure. So that is why it is named as B-tree. So it will be like this. Okay. For example, so what I am taking is I am taking the employee salaries. So in EMP table, assume salaries are like this. So one employee salary is 5000, one employee salary is 1000, one employee salary is 2500, one employee salary is 3000, one employee salary is 1500, one employee salary is 3000, one employee salary is 4000, one employee salary is 2000, like this. So in EMP table, employee salaries are like this. So one is 5000, 1000, 2500, 3000, etc. So I created index on salary column. When you create the index on salary column, so internally a tree structure is created, and the structure looks like this. Okay, a tree structure is created and the structure looks like this. Here in this tree, the each one is called one node. Like this is called one node, this is called one node, this is called one node, this is called one node. Each and every one is called one node, and these nodes are called index nodes, and these nodes are called data nodes. Okay, these nodes are called data nodes, and these nodes are called index nodes. So this leaf nodes, they are called leaf nodes, and these leaf nodes are called data nodes, and these nodes are non-leaf nodes, and these non-leaf nodes are called index nodes. Leaf nodes are called data nodes, and these nodes are non-leaf nodes. These nodes are called index nodes, and every index node contains a left pointer and a right pointer. Okay, every index node contains a left pointer and a value and right pointer. Left pointer, value, right pointer. See this, here there is a left pointer and there is a value 3000 and there is a right pointer, and this is also index node. This also contains a left pointer, a value 2000 and a right pointer. So this is the structure of the index node. Every index node contains a left pointer, right pointer, value. Next, every data node contains value, means index key, and star. And what is this star represents? The star represents row ID. Okay, every data node contains, means every leaf node contains index key and also star, and what is the star is row ID, and what is that row ID is address of the record. Here 100,000 star, what is 1000 star is address of the record whose salary equal to 1000. So every data node points to a record in the table. So here 1000 star, so 1000 star means row ID. So that means what is that contains is address of the record salary equal to 1000. 1500 star, 1500 star means row ID, address of the record whose salary equal to 1500. Next 2000 star, address of the record salary equals to 2000. and 2500 star address of the record salary equals to 2500. So every data node points to a record in the table. Okay. Then so using this structure, Oracle can locate the data fastly. So and every operation starts from root node. So this contains a left pointer and a right pointer, and the left pointer points to the nodes values less than 3000, and the right pointer points to the nodes values greater than or equals to 3000. A left pointer points to the nodes values less than 3000, and a right pointer points to the nodes values greater than or equals to 3000. Here also 2000, a left pointer, and this left pointer points to the nodes values less than 2000, and the right pointer points to the nodes values greater than or equals to 2000. Here 4000, and left pointer points to the nodes values less than 3000, 4000, and right pointer equal to or greater than 4000. For example, suppose you submitted a query. So what is that? So I want to get employee list. I want to get the employee list earning 3000 salary. I want to get the employee list earning 3000 salary. You submit this query to Oracle. You submit this query to Oracle. When you submit this query to Oracle, so assume index is not there. Assume there is no index on salary. When there is no index on salary, then what Oracle uses? Oracle uses table scan. So actually Oracle uses two methods. When you submit a query to Oracle server, Oracle uses two methods to access the data. Okay, then so data access methods there are two. One is table scan and another one index scan. Now assume suppose index is not there. If index is not there, then Oracle uses table scan. So when you submit this query to Oracle, suppose assume the case index is not there on salary column, then Oracle goes to table and it go to first record and checks salary equal to 3000 or not. Then and go to the second row, check salary equals to 3000 or not. Go to the third row, fourth row, fifth row, sixth row, seventh, eighth. It goes to each and every row and checks salary equals to 3000 or not. And this type of searching is called linear search. So it go to one by one row and checks employee salary equals to 3000 or not. Suppose assume the case the table contains huge amount of data. So there are millions of records. Going to one by one record, checking condition true or false is a time consuming process. Then so Oracle takes more time to locate the record salary equals to 3000. So if the table of contains huge amount of millions of records, then so definitely this query takes more time to locate the record. Suppose assume so index is there on salary column. See what I explained is I explained table scan. So I am going to explain index scan. How Oracle will get the records whose salary equals to 3000 through index. So when you submit this query to Oracle, so it goes to what? Index. So this is the index created on salary column. This is the index created on salary column. So first it goes to, so this is called index node, and what is the query? So salary equals to 3000. So I am searching for the record salary equals to 3000, and 3000 this 3000 is compared, takes right pointer. So what I said equal to or greater than takes right pointer, but the value is less than then takes left pointer. But so here this node is 3000, but I am searching for the record salary equals to 3000. So then equal to, when it is equal to then takes right pointer. Next one, and 4000 3000 is compared, then 4000 3000 is compared. So 3000 is less than 4000, then takes left pointer. So here left pointer. Now you have come to the data node. So these are all index nodes. Now you have come to the data node. So there is a data node with 3000. There is a data node with 3000 means there is a employee earning 3000 salary. Okay, there is a data node with 3000 means there is a employee earning 3000 salary. So here how many row IDs are there? 2 row IDs. 2 row IDs means what? There are 2 employees earning 3000 salary. So with the help of this row IDs, so Oracle goes to the table and get the records from the table. Okay, Oracle goes to the table and get the records from the table. So see this, how many comparisons. So this is one comparison, this is one comparison, and this is one comparison. Totally in how many comparisons? In 3 comparisons you are able to fetch employees earning 3000 salary. Same query, if you go to the table, then how many comparisons are required? 8 comparisons are required, because how many records are there in the table? 8 records are there, and how many comparisons are required? 8 comparisons are required. So that is why, so index makes data retrieval faster. So number of comparisons are reduced. When number of comparisons are reduced, and performance will be improved. So this is how the index improves what? Performance. Okay. And so even like you run the query, okay, you can run the query, and you can also check whether a particular query Oracle is using index scan or Oracle is using table scan for a particular query. So you run the query, and you can also check whether for that particular query Oracle is using index scan or table scan. Then how? So to know whether Oracle is using index scan or table scan, then see the execution plan. And how to see the execution plan? To see the execution plan, execute this command set auto trace on. So execute this command set auto trace on, explain. Set auto trace on, explain. So this is the command, just execute this command. What for this command is, after executing this command, so you execute the queries. When you execute the queries, it will show the output, and also it will show the execution plan used by Oracle to fetch the data. For example, so I will execute this query, select star from EMP where salary equals to 3000. Okay, I am executing a query, select star from EMP where salary equals to 3000. So let us execute this query, sir, and see this. Here there are 2 employees earning this 3000 salary. So one employee is Scott, one employee is Ford. Scott is one employee, Ford is one employee, both employees are earning 3000 salary. So when you run this query, it is showing the output and also showing execution plan. See that execution plan. So what the plan that Oracle is using? See, index range scan I1. So what the index that Oracle is using is index I1. That means to locate the records earning 3000 salary, Oracle is going to index and getting the data. So Oracle is getting the data through index. So through index always the query will be faster, and through table the query may be slow. For example, suppose I run one query. See, select star from EMP where salary greater than 3000, and for this query also Oracle is using index I1. For this query also Oracle is using index I1 to get the employees list earning 3000, more than 3000 salary. For this query also Oracle is using index I1. And for example, select star from EMP where salary less than or equals to 3000, and for this query also salary less than or equals to 3000, and for this query also Oracle uses index I1. Okay, for this query also Oracle is using index I1. Then for example, select star from EMP where ename equal to some Blake. So I want to search for employee record name equals to Blake. Then we will execute this query and we will see what Oracle uses, whether Oracle uses index scan or table scan. Now see this here. So it is showing the employee record whose name equals to Blake, but if you see this execution plan, so here Oracle is not using index, Oracle is using table access. Okay, so this is called table scan. Why Oracle is using table scan? Because so you created index on salary, but your where condition based on ename column. Index is there on salary column, but your where condition based on ename column. So there is no index on ename. When there is no index on ename, Oracle uses table scan. When index is there, Oracle uses index scan, but if index is not available, Oracle uses table scan. So this is how index works. Okay, and thank you for watching this video.